All right, students, today's discussion, we're going to discuss chemical bonding specifically. We'll talk about why atoms bond in the first place, and then we're going to focus on ionic bonds for today. At a later point, we'll talk about the other two types of bonding, which we'll briefly mention in today's discussion. So first of all, let's answer the question, why atoms bond? We've learned in other chapters about valence electrons. And valence electrons are the outermost electrons on the outermost energy level, and they are the ones involved in the bonding process. And the only ones. We don't care if an atom has 32 or 82 electrons. We only care about the valence electrons, which means there could be only a maximum of 8 valence electrons, or 8 electrons involved in the bonding process. And normal atoms are unstable because they exist at high energy states. And we've already learned that electrons, particularly valence electrons, like to lose energy, not have high energy. So this is a problem. And the way that atoms go about losing energy is to reach 8 valence electrons. Why 8? We don't know why 8 is the magical number. My answer to that would be because God designed it that way, as He does many things in this universe. But we do know that atoms lose energy to become stable when they reach 8 valence electrons. So if you look at the periodic table here, that pretty much includes everything but the noble gases over here on the far right side. Everything else on the periodic table here that we have, all these other elements, other than the noble gases that we learned about last chapter, have less than 8 valence electrons. So because of that, they're unstable. Therefore, they need to go through the process of bonding. So how does bonding help if they have these high energy states? Well, bonding is the process by which atoms gain 8 valence electrons. And they can do that through a number of different ways, and that's kind of what we're going to discuss and talk about as we look at the different types of bonding. But that is the main goal of an atom when it bonds, is to gain 8 valence electrons. We sometimes refer to this as a chemical reaction, which is basically what it is. So to sum it up, basically the simplest way to say it is atoms bond with the point to lose energy. They have high energy states. They want to lose that energy by gaining or getting to the state where they have 8 valence electrons. And so they will bond with other atoms, and it can be one atom, it can be 2 atoms, it can be 4 atoms. In some cases, it can be an incredible amount of atoms to gain that those 8 valence electrons. There's a couple rules to keep in mind as we go through here that kind of govern the bonding process. The first is what we call the octet rule, which governs the majority of elements on the periodic table, the majority of atoms. And that is the tendency for atoms to react with other atoms until they have 8 valence electrons. Once they have 8, they're completed, their valence shell is full, they've lost the maximum amount of energy, they're good. There are a few atoms that follow what's called the duet rule. Hydrogen, helium, lithium are kind of these are small atoms. Hydrogen and helium are kind of the main ones we'll focus in on, and they only need 2 valence electrons instead of 8, basically because they reside only on energy level 1, which can only handle 2 valence electrons. Hydrogen is really the only one we're concerned with here because helium's already full, so it's kind of irrelevant. Hydrogen is the main one that we're going to focus on needing 2. So anytime we draw hydrogen, that's what we'll deal with. So what are some of the types of bonding? This is one of the things on the test that you're going to have to be able to do, is I will give you some compounds, and then you're going to have to identify what kind of bond it is. And it should be fairly simple. So you have an ionic bond, which is electrostatic attractions, which we learned last chapter, were attractions between oppositely charged, a positive and a negative. It could be between protons and electrons. It could also be between atoms that have a positive and a negative charge. These are always solids, and the way to identify these, this is always a metal, which will be your positive charge, and a non-metal, which will be your negative charge. And then opposites attract to each other. That we call an ionic bond because it involves ions. Your second type of bond is a covalent bond. And these are bonds consisting of shared electrons. So this would be a situation where neither atom wants to give up its electrons. They both want to actually receive electrons in this case. So what they do is they end up sharing. And this would be a nonmetal with a nonmetal. And if you remember our trends here from last chapter, if you think about the metals, they wanted to lose electrons. We call that ionization energy. They have a low ionization energy and a high and a low electron affinity. And so they're not likely to receive electrons, but they're likely to give them off. The nonmetals, on the other hand, have a high electron affinity, but also a high ionization energy. So it's hard for them to get rid of an valence electron, but it's easy for them to gain an electron. So you put that together, and so metals can lose electrons, nonmetals can gain electrons. So metals can form positive ions, nonmetals can form negative ions. So that works very well for ionic bonds. Covalent bonds, they both want to gain electrons, and so what you end up with is they end up sharing instead of losing. The last one is metallic bonds, and this is a metal with a metal with a metal, as the name kind of implies, and we'll talk more about what that involves at a later date. Again, if we go back to the periodic table, you can kind of look and see this side here being your nonmetals, and this side over here to the left of the stair step being your metals. And so the left of the stair step, these are going to be the guys who are going to typically lose electrons and become positive ions. Some of them will lose one, some of them will lose two, some of them will lose more than that. Over here, you have your nonmetals, and they will be gaining electrons. And so that's what you can kind of use the periodic table for. And you see a compound, and you see a guy over here, let's say magnesium, and magnesium is bonding with, let's say, sulfur. You can tell that magnesium is a metal, sulfur is a nonmetal, so therefore that's an ionic bond. If I have something like, let's pick sulfur again, bonding with phosphorus, those are both nonmetals, so that would be a covalent bond where there's sharing of electrons. So that's kind of what you'll see on the test, is I will pick a number of compounds, and you just have to take a look. What do I have? Do I have a metal bonding with a metal? Do I have a nonmetal with a nonmetal? Do I have a metal bonding with a nonmetal? What type of bond would that be? All right, what is an ionic bond? We're going to take a closer look at this. In an ionic bond, atoms either gain or lose electrons, what we call the transfer of electrons. And the whole purpose behind this, the reason why they're gaining or losing electrons, we kind of talked about some of the periodic trends, or we mentioned those briefly already: electron affinity, ionization energy. And so metals tend to lose electrons, nonmetals tend to gain electrons, and because they've lost or gained electrons, it results in an ion or a charged atom. So you have a positive and a negative, and sometimes they can lose more than one electron, or sometimes they can gain more than one electron. And so you may end up with a positive 2 charge or a negative 2 charge, or we write it as 2 plus, okay, or 2 negative in those cases. And one of the basic rules of science that we know is opposite charges attract. Very similar. You think of magnets and opposite poles attract. We've also talked about the opposite charges attract. What we call, our fancy name for that is electrostatic attraction. We've talked about the attraction between the nucleus and the protons in the nucleus and the electrons on the outside as they go around the atom. And because you have an atom that is now positive and an atom that is now negative, that electrostatic attraction brings those two atoms together and holds them in a very, very tight bond. And we call that an ionic bond because it's ions that are being held together in that bond, and it creates a new substance, or what we call a molecule in essence. This would be an example of what goes on here. You have sodium with its 1 valence electron, and you have chlorine with its 7 valence electrons. And initially, those two atoms are separated from each other. And sodium gives off its 1 valence electron. And the reason sodium is going to give off that 1 valence electron, if we went back to our periodic table, you would notice that 1 valence electron is on energy level 3. Once that valence electron is gone, there are zero electrons on energy level 3. So now our outermost electrons are on energy level 2. And since energy level 2 is already full, it has 8 valence electrons already. Now sodium has 8 valence electrons. By losing one, it went down to, in a sense, gained 8 by losing one because it went down in energy level. Chlorine, on the other hand, is not going to lose 7. It's much easier to lose 1 or 2 electrons. It's not easy to lose 7 or 6 valence electrons. So it's much easier to gain one, so it did that. Again, and this is where electron affinity comes in. Chlorine has a high electron affinity, so it wants to gain an electron. So it does. It gains an electron, and now it has 8. As you can see, count them up. 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. It's lost energy. It's satisfied. But what we have now with sodium over here, it has a positive charge, and chlorine now has a negative charge. And because of that, they're going to join together, and they become sodium chloride, or what we refer to as table salt sometimes. Ionic bonding involves the transfer of electrons. So the electron is moving from one atom, the metal, to the non-metal. That is always the case in ionic bonds. And we'll show you in class, we'll talk about in class, how to draw using electron dot structure or Lewis dot structure, what's going on between any two atoms when they're losing or transferring electrons. We'll show you how to draw that just in a quick, easy way. Okay, ionic bonds. When they form, all ionic bonds form solids, and those solids we call crystals. And basically what a crystal is, it's a solid arranged in an orderly pattern. And we'll do some work with this in class where we kind of mess around with building orderly patterns or orderly structures in class and deal with that. But that's basically what it is, and they can be a one-to-one pattern, like you had sodium and chlorine were arranged in a one-to-one pattern, and they kind of arrange themselves in that very orderly structure, or they can be arranged in a 1-to-2 or 1-to-3 pattern, or a 2-to-3. It depends, and we'll look a little bit more closely at that. When an ionic compound comes together, in class, we'll probably, just for sake of ease, we'll refer to them as molecules, but the technical name is, we call them formula units. And you'll see them written like this. For example, sodium chloride, right down here, in a 1-to-1 ratio, because you have 1 sodium to every 1 chlorine. And that's how we write a formula unit. It's always written in the lowest whole number ratio. So even if I had 100 or 1,000 or 1,000,000 sodiums and 1,000,000 chlorines, I don't write it that way. I would write it in the lowest whole number ratio, which in this case is a 1-to-1 ratio. With magnesium and fluorine, it's a 1-to-2 ratio, so I write it MgF2 is how I write it. And we'll do some practice with this in class. So again, even if I had, let's say, 50 magnesium and 100 fluorines, I write it in the ratio that they are to each other, which is a 1-to-2 ratio. And the metal is always written first, and the non-metal is always written second in the formula unit. And so just for quick practice at home, take this. If you know that they are always written, here you have aluminum, which is a metal, and you have sulfur, which is a non-metal. And if I told you you had 6 aluminums and 9 sulfurs, as you see here, what would be the correct way to write this? So that's kind of your last little bit of homework. We'll do some more practice with this in class so that you guys kind of understand the idea behind ionic bonds. I will see you in class.